Thank you for joining us for the ECA Southern California Winter 2024 workshop. My name is Mark Benthey, and I'm the Executive Director of Earthquake Country Alliance, also Director for Communication, Education, and Outreach at the now statewide California Earthquake Center, headquartered at USC. This is a regular Zoom meeting. It is not a webinar, so if we do ask, of course, keep your sound muted, except when you might be speaking. Keep your camera on so we can see you. It's an optional, of course, but remember it's on. And if you like to have a transcript, you can click that option. May vary between your device. You can adjust those settings too to see those. And we will be looking at the chat for questions and any comments that you're having, and we'll be putting links there that related to the topics of the discussion of the meeting. So definitely be looking at the chat, have that open as we go through. So we just had a few more people joining us. For those just did, keep your sound muted. And remember, if you have your camera on, that it's on. Again, welcome to the ECA Southern California Winter 2024 workshop. ECA, of course, is a statewide partnership of public and private and grassroots leaders with subject matter committees developing resources and programs that you can be a part of. Regional alliances from ECA SoCal in the South, for which is hosting today's webinar. I know we've invited everyone on our list statewide to join. So welcome to those of you from perhaps in the Central Coast, Bay Area, or Northern California areas, including the Redwood Coast Tsunami Work Group. And just to acknowledge that our funding comes from California Office of Emergency Services with FEMA support that helps us coordinate ECA's activities. And this slide is needs updating because, as I said, we are no longer Southern California Earthquake Center. We are now statewide California Earthquake Center, and you can join us at earthquakecountry.org/join if you're not already on our email list to get updates on activities as they come up. I'd like to now introduce and turn over to the meeting to the ECA SoCal Coordinating Committee co-chairs. We'll just go ahead and turn it to Alan for the initial welcome.
Oh, well, it's great to have you here. We have a fantastic program today, and looking forward to not just a Southern California focused agenda, but something that would be beneficial for the whole state. So nice to have you here. And Margaret, take it away.
Okay, thank you, Alan. So good morning to all of our ECA partners. I'm Margaret Vinci, Manager of the Office of Earthquake Programs at Caltech Seismological Laboratory, and co-chair with Alan and Heidi of your Southern California ECA coordinating committees. Our committees, you can see here, are all led by a talented group of ECA partner coordinators. And we'd also like you to kind of peruse this list and look and see and consider joining any one of our coordinating committees. We meet quarterly to support and coordinate efforts to improve earthquake and tsunami resiliency. And I'd like to then now introduce our third co-chair, which is Heidi Rosinski.
Did we Heidi?
Did we lose Heidi? Muted. Oh, she's muted.
Okay, there we go. It's been an interesting morning. We would, we want to welcome you, and we're going to talk a little bit about today's agenda and the speakers that are going to be presenting. Lori Dingler, who I can't speak today. We're going to have a report on the 1964 Alaskan earthquake and tsunami warning systems. we're also going to have Charles Scarn on climate change effects and earthquake risk, our early warning and quake break system, a wonderful presentation on community change and looking for equitable resilience. And then, as you can see, we've got, discussion of our ongoing activities and opportunities regarding mini awards update and what's going on with the Northridge Quake anniversary. And I know Mark's going to be talking about the Quake Heroes Expo. We will also be talking about what's going on with you in terms of announcements, discussion on sharing that information, and an opportunity to be able to talk about something that came to mind or that it's applicable to what's going on in your area about the program that we have, and any, like I said, any announcements, anything you want to share. And I apologize for being a little bit kind of having difficulty speaking. I have a disability and it's creating a problem for me. So I appreciate your hanging in there with me. And I would say, and on that note, I'm going to go to Alan. So Alan, it's your turn.
Actually, I think it's Margaret. Go ahead, Margaret.
Actually, it's going to be me, but thank you so much, Heidi, for that introduction of our agenda. So I am very proud to introduce our first speaker, Dr. Lori Dengler. Lori has been a friend and a partner of Earthquake Country Alliance for over 14 years. She served as professor and chair of the geology department at Humboldt State University in Arcata, California, and is an international expert on tsunami education and mitigation, and has been a tireless force in preparing coastal communities in California and around the world for tsunamis. As always, it is a great opportunity to learn something new from Lori. And Lori, I'm going to turn it over to you.
Thank you very much. Hopefully everyone can hear me. I'm going to give you the California perspective on an event that happened almost 60 years ago. So coming up in March 27th, March 28th, the Great Good Friday Alaska earthquake that really started a major change in our perception of tsunami hazards, really internationally, but particularly in California. Next one. So I want to set the scene. Where were we at in March of 1964? We had a tsunami warning system. Fortunately or unfortunately, from the perspective of Hawaii, the 1946 Aleutians earthquake and April Fool's Day tsunami in Hawaii, still the worst ever in terms of US tsunami casualties, did establish, took a couple of years, the Honolulu Observatory. So in 1964, our tsunami warning system basically looked like this photograph. This was before real-time information. There was no data telemetered in. They did have a seismograph. So basically that was their information, was their own seismograph. And seismic observatories around the Pacific would phone in the P wave arrival times. Now, it's important to understand what is considered a successful alert, and we'd use this same definition today. People evacuate before the waves arrive, and there are no deaths or injuries. The new tsunami center was tested quite quickly, successful alerts to Hawaii in 1952 and 57 after the great earthquakes in the Aleutians and Kamchatka. Not so successful in May of 1960 when 61 people in Hawaii died, many more in Japan after the 9.5 earthquake. I was able to get the Honolulu Observatory log of what happened in those very late hours of March 27th, early hours of March 28th, 1964. All of these times are California times. So this earthquake occurs at 7:36 p.m. in the evening on Good Friday. It takes 8 minutes before an alarm is sounded because this was a holiday in 1964, and we didn't staff the tsunami warning centers 24/7. So it takes 8 minutes for their to hear an alarm that's based on the seismograph that says, hey, there's a big earthquake. And then the staff come to the center, and it takes another half hour before they even notify the observatories in the Pacific, hey, we need some data, because you really can't locate it with only one seismograph. So over the next hour, we get reports from Manila, Hong Kong, Guam, Japan, Berkeley, and Tucson. And it takes an hour and 16 minutes to get that first estimate of the location. We're actually not getting any information from Alaska. So it's important to understand that Alaska is dark. Here's the first bulletin, 86 minutes after the earthquake. At that time, we didn't call them tsunamis. So a tidal wave seismic sea advisory, remember a tsunami is not a tidal wave, that mentions that the earthquake has occurred, its location. There's no mention of magnitude. We actually don't get a good magnitude, a modern magnitude, for a number of years, because it turns out the magnitude estimates at that time weren't really able to get a good estimate of these great earthquakes. At this point, we don't know if there's been a tsunami. There is an estimated arrival time, an ETA, for Hawaii. Remember, the Honolulu Observatory is very Hawaiian-centric. This is the first time they're dealing with a tsunami that might affect areas other than Hawaii. Well, 1960 affected California as well, as we'll see in a moment, but not in a major way. Next. Almost 2 hours after the earthquake, we get the second bulletin. And these bulletins are not sent as they are now to all of the operational centers along the coast. They just go to the state operations. And at this point, it was called the California Disaster Office. So this bulletin goes to the California Disaster Office, and it's the first mention of California locations, which I've highlighted in yellow. The earliest arrival time is obviously Northern California, Crescent City. All of these times are in Universal Time or Zulu time. So about midnight is when they expect the arrival of the tsunami in Crescent City. Next slide, please. Go back one. We've jumped. Okay, no, actually, this is, So it, for reasons we don't understand, the California Disaster Office sits on this information for about an hour and a half. I've never been able to figure out why. And they don't issue a bulletin to the counties until after 11 p.m. That bulletin does not mention the expected arrival time. Now we're ready for the next. So this is the picture. Obviously greatly exaggerated. You couldn't see a tsunami in the water like this, but so great vertical exaggeration, but it gives you a sense of what the tsunami, where it was when that first alert to California counties came out. About 52 minutes before they estimated the first surge would arrive in Crescent City. Obviously, a little more time as you go further south in California. Next slide. Now, let's sort of look at where we are in terms of the ambient conditions. Really important what the tide is doing. In 2011, California was very lucky that the largest surges from the Japan tsunami occurred at the lowest tide. Unfortunately, in 1964, it was just the opposite. So this is the actual merogram from Crescent City. And the red line is that recording, and high tide, about an 8-foot tide, occurred shortly after that first bulletin. And so the little black arrow shows when that civil defense notification came in, and all of these subsequent slides are showing you, will show that little arrow. And at that point, the Del Norte County folks really do get into action, and they start going door to door, telling people to evacuate. Crescent City has had the experience only 4 years earlier of the Chile tsunami, which did cause some damage and flooding. So there certainly was awareness. Here we are now. The first surge has come in and is starting to ebb. And it's pretty significant. We're talking about a peak water height of over 14 feet above what we call mean lower low water, our sort of reference level. The amplitude of that surge is about 5.5 feet. Amplitude is the height between the tide and the maximum peak or trough. Notifications had not been completed before that first surge arrived. Next slide. We actually have a pretty good idea of what it may have looked like. Now, remember, this is all happening at midnight, roughly midnight. There was a full moon that day, so people were actually able to see quite a bit. And I talked to a number of people who had been in the area back in '64, and they sketched out roughly what they thought the first tsunami surge flooded, and that's shown on the left in the blue. And if you zoom into that little box, it probably looked a lot like this, because everyone said, oh yeah, the first surge did almost exactly what happened in 1960 from the Chilean tsunami. So flooding close to the harbor, almost up to Front Street, but no damage in the city itself. So then a second surge comes in, and it is not as big. And that, I think, is psychologically important. Remember, people in Crescent City knew something about tsunamis. The first surge flooded the area almost exactly as it had done so only 4 years beforehand. Second surge is not as big. Next. Then we have almost an hour where there is no tsunami, apparently no tsunami activity. This tide gauge, nobody is seeing it. It's not retrieved until days later. There's no real-time information. So from your perspective in Crescent City, nothing much is happening. Unfortunately, this is not the end of the tsunami. During that period where nothing much is happening, many people go back to the coast. They want to check on their businesses, their homes. Some of them just want to watch and see, and some even wanted to party. But a third wave comes in starting around 1 a.m. And it's definitely bigger. In fact, it's so big that it breaks the tide gauge, roughly 1 a.m. And there's a photo on the left that shows that damaged tide gauge station. It's fortunate they were able to retrieve the record at all. So from this point, we don't know the actual water heights. We have to use the observations of the eyewitnesses, roughly maybe 1:20 a.m. and definitely bigger than the first. Next. Most eyewitnesses describe 4 significant surges. The last one, roughly 1:45 a.m., definitely the largest. And we have a pretty good estimate of how high it was because the big breakwater to the west was overtopped. You can see in the photo on the left, all of the debris piled up along the harbor side. The tsunami did not enter from the west. It entered from the south. Has to do with the bathymetry of the harbor. But it just barely overtopped that breakwater. And so relative to mean lower low water, that was about 22 feet high. Next. We also know a lot about what happened in Crescent City thanks to Orville Magoon, who an Army Corps of Engineers engineer at the time, fascinated by tsunamis. He got permission to come up with an assistant and spend a couple of days mapping the damage in Crescent City. And his original map is shown here on the right. I had a student who digitized it. That map, Claudia Velasco's map, is on the left. And you can see the color ramp is the topography. The lines are Orville's inundation heights. You can see, not surprisingly, the inundation is very closely linked to the topography. 29 city blocks flooded. And basically the end of Crescent City's downtown. The city center was pretty much never rebuilt. Next. So here's an eagle's eye vision of the harbor area before, a couple of years before, and then only a few days after. You can see that it has made significant impacts in the harbor. Next. It's important to remember that 64 was not just a Crescent City, Del Norte County event. On the right, we're seeing the little bars, and the numbers next to them are amplitudes in feet. So not the actual water height. Water height was higher because it was riding on high tide. But you can see that we have significant tsunami. Most of these are from tide gauge measurements. Some are eyewitnesses running the entire length of the state. 21 locations in California reported damage, and many of those were in Southern California. At least 30 million in 1964 dollars in damage. The greatest damage in terms of dollars actually occurred in San Francisco Bay. 13 deaths that we're pretty sure were related to that tsunami, 10 in Crescent City, 1 at the mouth of the Klamath River, 1 in Bolinas, and 1 person did die in the LA harbor at Long Beach. A longshoreman was killed when a ship he was working on hit a surge, and the chain snapped and broke his neck. So there are impacts of tsunamis that are not necessarily due to being flooded. That tsunami changed our tsunami alerting system. In 1967, 3 regional centers were established in Alaska. One of those in Palmer is what persists today. And they were tasked with, had a very limited task, which was to provide information to coastal areas of Alaska specifically. They weren't alarming, issuing alerts to the rest of the West Coast. And the Pacific Tsunami Warning Center, which is what it becomes in '68, still has the responsibility for the general monitoring of earthquake and tsunami potential. But in 1982, Palmer, the only one of those original 3 that continued, was given the responsibility of issuing alerts to Alaska and us, everybody on the West Coast, for an earthquake that might produce a tsunami that is centered in our region. In other words, if the earthquake is out there in Japan, the Pacific Tsunami Warning Center is still going to send us the bulletin. But if the earthquake's in Alaska or California, then the Palmer Center. In 1996, it becomes the West Coast Alaska Tsunami Warning Center when they've decided, boy, that system doesn't work very well. Any tsunamigenic earthquake in the Pacific, Palmer is going to send the information to those of us on the West Coast. In 2013, the name gets changed to the National Tsunami Warning Center. Next slide. So this is what it looks like today. In red are the area of responsibility for the National Tsunami Warning Center. In orange is the Pacific Tsunami Warning Center. We still have 2 separate centers today. And they do send out bulletins, but if you're in California, only pay attention to those coming from the National Tsunami Warning Center. So a little bit about how things are different today than where they were in 1964. Obviously, we have a tsunami warning center that now operates 24/7. With hardened communication and all sorts of telemetered real-time information on both earthquakes, water level data. We also have a system of about 35 deep ocean water level sensors, the DART system. We have the ability to forecast not only the expected arrival time of the first surge, but the likely peak amplitude. In 2011, the system gave us incredibly accurate maximum amplitudes in California. The peak amplitude at Crescent City was estimated to be 2.5 meters. It actually was 2.47. I'd call that incredible. We have evacuation maps for most of the West Coast. We have the Tsunami Ready program to strengthen the ability of local jurisdictions to both receive tsunami information and to act on it. exercises for emergency managers, and all kinds of tsunami preparedness and outreach programs. So if 1964 were to happen today, how would it differ from what happened 60 years ago? We would probably get our first bulletin within 4 minutes of the earthquake. The initial magnitude might not be super accurate. I'll make a guess that we make it into the low to mid 8s, but it would be large enough to immediately place all of Alaska into a warning, meaning you got to get out of Dodge really quickly. And California is most likely going to get a watch for that very first bulletin. That's because we're still going to be 4 to 4.5 hours away from the first wave arrival, even in the northernmost part of the state. That first bulletin is going to include the estimated time of arrivals for a number of locations along the California coast. Subsequent bulletins are likely to come out every half hour. If the DART data and other analyses confirm a tsunami threat, and if this is the 64 tsunami all over again, it will, then as the wave arrival gets closer, or they've really confirmed that we're looking at a very large tsunami, we will get placed in warning status at least 3 hours before the expected time of arrival. There will be hourly conference calls between folks in the state, the operational areas, and the National Tsunami Warning Center. The operational areas will authorize evacuations as appropriate. People will be notified by a variety of systems, including emergency notifications, EAS activation, and so forth. One back. Even with a perfect notification system, we still have a huge challenge: getting people to move off the beach and stay away from the coast. Back in 2022, we tested the system with the Tonga tsunami, and there were a number of rescues and injuries of people that were in the ocean when they shouldn't have been. A number of problems in keeping awareness up. We have short memories, and tsunamis are relatively infrequent. We are constantly changing emergency management personnel. So the folks that were operating when the Tonga tsunami event are likely not to be in town when the next tsunami hits. Lots of confusion still about what tsunamis are and how long the danger period is. In the era of social media and artificial intelligence, we can spin a whole lot of misinformation and rumors. And of course, the next tsunami won't be anything like the last. The next tsunami won't be a 64 or a Tonga. It'll be something different. And if it's nearby, I've been really focusing on the tsunami that's coming from far away. When we're talking about the tsunami that's coming from nearby, we've got a whole different set of educational messages. Next. Lots of things in the future to look forward to. The reorganization of NOAA's tsunami program. It really does look like we're finally going to see both tsunami warning centers put under a single administrative system, developing the same platforms and protocols so they can truly back each other up. Lots of exciting new technology to improve both the rapid estimation of earthquake size and also the good side of machine learning and artificial intelligence, it may be able to give us a much more rapid and accurate forecast of tsunami wave characteristics. And need to keep looking at how people behave, because we can have a great warning system, but if we don't understand how people respond to it, we're still not going to save lives. So drill, baby, drill. And thank you very much.
Thank you so much, Lori. This was a great presentation. I always learn something new from you. So this is wonderful. It's also a reminder that March 23rd to the 31st is Tsunami Week to bring awareness and preparedness. And Mark's going to talk about that a little bit later in the morning. But we'll open it up for questions and answers. And I think that Gabby, you're going to monitor the chat questions that have come in.
No questions came in. There was one about the recordings being available after the meeting, and yes, we will share
I have a
it.
question.
Mhm.
I have a question, if I
Go
may.
ahead.
Go ahead.
Lori, thank you very much for your talk. You said that I actually have two questions. First question, you said we should, in California, we should only pay attention to the warnings from the National Tsunami Warning Center. I believe you said that.
Yes.
And I was curious because they're only responsible for, if I understood correctly, the tsunamis that are generated within a certain area. And the Pacific.
No.
Okay.
That changed in 1996.
So the Pacific Tsunami Warning Center, we should not pay attention to their warnings?
Correct. So let me explain, because it's important to understand the difference. Both tsunami warning centers monitor the entire Pacific for potential tsunamis that could affect their area of responsibility. The Pacific Tsunami Warning Center is also responsible for at least 26 countries in the Pacific, in addition to Hawaii and the US territories. When an earthquake happens, and there's a big sort of template that says, okay, we have a magnitude 7.5 earthquake in the Aleutians, then this is what the Pacific Tsunami Warning Center will say, and this is what the National Tsunami Warning Center will say. And the problem is that right now, those messages are separate. They're written in very different ways. And Pacific Tsunami Warning Center could issue a tsunami threat message, for example, for Samoa. They could issue a tsunami warning for American Samoa. It gets very quickly, but we can't issue warnings to foreign countries. And the National Tsunami Warning Center for that same event would say there's no threat at all along the US or Canadian West Coast. I'm hoping that when these two centers actually the system gets more integrated, we will end up with messages more like what you get from the National Hurricane Center, which is, regardless of where the hurricane is, you get a single sort of consistent message. But at this point, if you see that a tsunami warning has been issued by the Pacific Tsunami Warning Center, that doesn't necessarily mean that there's a warning here. Tsunami.gov is the place to go for quick updates on the tsunami threat. But fortunately, all California counties now they have emergency notification systems. There is, if we're talking about something like Alaska, it will definitely go out on wireless emergency alerts. It'll trigger telephone and radio. But it's also important to realize that our tsunami warning system is continuously evolving. And in another year or two, we may use completely different terminologies
Okay,
for
thank you. I got
various
it.
threat levels.
Thank you. Thank you.
Just one last question is asked, how are the bulletins in that tsunami transmitted from country to country and state to state at the time? How that were distributed?
Sure. So if we're talking about the international system, through UNESCO, there is an International Oceanographic Commission that has basically contracted with PTWC for these member countries to get these threat bulletins. Then it's up to the individual country to decide if there's going to be.
Was that what was in place in 1964? Because that's what they're asking. How were they then distributed?
Oh, in 1964, there was no interaction to other countries. So basically in 64, we had the Honolulu Observatory, nothing else. And the Honolulu Observatory had no obligations to any other countries.
Thank you.
So things have come along since then.
Laurie, thank you so much again for your presentation and for being with us today. And we've already had a question from our next presenter, and we'll let Alan take over to introduce our next presenter.
Thank you, Mark. Well, it's my pleasure to introduce Charles Gawthorne. So he is internationally recognized as an authority for the analysis and mitigation of natural and technological hazards. He retired in 2008 as a professor and head of the Earthquake Disaster Prevention Systems Laboratory at Kyoto University in Japan. This bio is rather lengthy, so I'm going to skip around a little bit.
Good.
He's now
Yes, you can skip it all, Alan.
He's now the president of SPA or SPA Risk LLC. He consults the global insurance industry, the World Bank, FEMA, Global 1000 corporations, and I saw he was involved with the Haywire scenario as well. He has done risk analysis for seismic vulnerability of the U.S. national infrastructure, scholastic models of fires following earthquakes. I thought that was interesting. And this presentation is specifically on the effects of climate change on earthquake risk. So Charles, or Charlie, as you prefer, take it away.
Thanks so much. Thank you, Alan. Sorry about the lengthy bio. Good morning, ladies and gentlemen. I'd like to speak to you today about and I hope you can see my screen, about climate change effects on earthquake risk. Let me try to minimize. Okay. And you'll notice that it's the effects on earthquake risk, emphasis on risk, although they do have even some effects on earthquake generation. So let me get into that. A number of years ago, I developed the concept of the earthquake risk chain of causation, which is shown here. And it basically begins with earthquake hazard, the shaking and other things like liquefaction, landsliding, proceeds through the damage and vulnerability to result in the loss or risk. And some further detail is shown on the right. The benefit of thinking of the risk chain of causation in this manner is that a chain is only as strong as its weakest link. And if we can break the chain, we can reduce the risk. And every link in that chain, at every link in that chain, there is a mitigation opportunity. And they're shown here on the left, such as earthquake early warning or bracing of buildings or improving emergency planning. And you can see that they impact that particular link, and the benefit is shown on the right. So using this concept, we can also use this concept to look at the effects of climate change. And climate change, fundamentally, at least from our perspective right now, I think, the fundamental phenomena we're concerned about is global warming. There are other phenomena, but global warming is perhaps the one that is most relevant here. And that leads to such things as heat waves, loss of polar ice, sea level rise, and so on. Greater cyclone frequency or intensity, and also drought, more wildfires, and changing wind patterns, such as the Santa Ana winds in Southern California, which are more general, and in Northern California, we term these Diablo winds, and they're more generally known as Föhn wind conditions. Now, each of these also can impact some, or has an impact at some link in that chain. So let's go through each of these and look at how they impact that chain of causation. There are also two overarching impacts, and one of those will be, or maybe, migration, human migration, and population shifts. With climate change, it is probable we will have pressures on people, and they will be migrating. And this, one of the impacts of this, there will be many, of course, but one of them will be more construction, the pressure from more construction on more seismically hazardous sites. Not only seismically hazardous, of course, but floodplains and other places. Another overarching impact, and more specifically, perhaps to some in the audience, is the increasing competition for mitigation funds, which in the earthquake field we term mitigation, and actually in the climate field, mitigation has another meaning, and it's called adaptation. So, but the funding, both the research funding and so on, and this implies to some people that there's a smaller piece of the pie for the earthquake research and mitigation field, but that assumes a zero sum, and that's not necessarily true, and I'll discuss that more when I get to that point. So let's jump into this. What is the climate change effect on seismic hazard? Well, you might think there isn't any, but I think we're all familiar with the concept of glacial rebound and earthquakes that result from that, particularly in the higher and lower latitudes. And this map by Paulson and others shows the rates of post-glacial rebound in, again, the northern and southern latitudes. And with climate change and shrinking polar ice caps, we're likely to get more rebound. And this has been looked into by a number of people. For example, Kim et al. Have looked at this for the Korean Peninsula, and this is their paper. And they've found that the ongoing global warming trends, excuse me, will probably increase the earthquake frequency on the Korean Peninsula. That's the earthquake frequency. You wouldn't think climate change is going to affect earthquake frequency, but various investigators are finding this. Also, for example, in the Himalayas, Devendra and others have been looking at the effects of rainfall. And this shows a very strong correlation. And of course, rainfall is going to change with climate change. And this graph from their paper, the upper, the blue line is the periodicity of seasonal rainfall. It's very, regular with the seasons. And the yellow, the bars, the yellow, blue, and green bars are the numbers of earthquakes. And it shows a very clear trend with seasonal rainfall patterns. So, and this is in the Himalayas. So it is, it's these studies and others suggest that climate change will actually be affecting earthquake genesis, which is the one thing that people probably jump to the assumption that it won't be happening, but it looks like it may be happening. There are other studies in this regard also. Of course, earthquakes cause many effects, such as liquefaction and landsliding and so on. How will climate change affect those? Well, this has been studied, for example, by the USGS in the Bay Area. And this study showed, they looked at liquefaction, and of course, with sea level rise, you're going to have, at least in the lowest lying areas, probably a rise in groundwater level, which clearly affects, probably increases the effect of liquefaction. And this has been demonstrated here in the Bay Area, by a USGS study, but it's been looked at in other regions also, such as, for example, in the Middle East, in the Aqaba Eilat region by Abdel Rahman and others. We found that the increase in the area of high liquefaction due to sea level rise is going to increase by 26 to roughly 50%, significant increase in liquefaction, in the area of liquefaction potential. And Quilter and others looked at the same phenomena in New Zealand area and the effect of sea level rise on liquefaction vulnerability. And they found that it would increase the probability of a 0.5 to 1 meter sea level rise would increase liquefaction manifestation 2 to 4 times for the Christchurch area. So liquefaction is, at least in the lower lying areas, is definitely going to probably increase with climate change. Landsliding. This has been looked at in the Vancouver area by Jacob and others, and they've found that the increase, they anticipate an increase of up to 300% in the frequency of shallow landslides in the British Columbia area, and an increase in volume of those landslides of perhaps 50%, given the particular climate change scenario, which the IPCC terms the relative concentration path 8.5. There are a number of, as most of you know, there are a number of climate change scenarios, and all of these estimates depend on which scenario you're using. The same thing has been looked at by Loesch and others, and what they found is very interesting. They actually found that post-earthquake landslide activity correlates with the ground surface temperature, not post-seismic landslide, but post-earthquake landslide activity. They don't actually provide a physical rationale for this. They're simply looking at a correlation. But they find that the land surface temperature explains post-earthquake landsliding, while again, it has no visible effect on the co-seismic scene. Therefore, with climate change and increasing land surface temperature, it's possible this will be increasing landslides, post-earthquake landslides also. With regard to flooding, well, we've just heard an excellent talk by Professor Dengler on tsunami hazard, and it's clear with sea level rise, we're going to most likely, vis-a-vis our current built environment, sea level rise will probably increase our tsunami hazard also. This has been looked at. Sepulveda and all, for example, looked at it in the Hong Kong area, and they found here that depending on the risk level, that the tsunami hazard with and without sea level rise would increase by factors of significantly, as shown in the graph here on the right. And I won't belabor that point about the tsunami. That's rather obvious that sea level rise is going to increase tsunami hazard. But other flooding impacts will probably, seismically related flooding impacts will probably also increase with tsunami hazard in terms of greater rainfall and the earthquake effects on levees of rivers and so on. I mentioned migration before, and what patterns of migration are going to occur in our political landscape is very hard to estimate. I'm not going to try to do that, but it is instructive to look at migration just within the United States. And in the 2000, this has been mapped, and here this shows a mapping of migration in the 2010s decade, where red is a outward migration, and the blue shades are an inward migration. And you see a somewhat heterogeneous pattern here, but there are trends that you can see from more rural areas in the West and Midwest towards more urbanized areas, for example, Pacific Northwest, Florida, Northeast. In California, there's been a lot of talk recently about people leaving California. And of course, this data is perhaps 10 years old. But even here, you can see California's got some inward and some outward migration. But it's interesting to compare this map with the same similar map for the 1950s, in which the migration patterns within the United States were much starker. And what we see here is clear outward migration from agricultural areas in general to urbanized and industrial areas, and the picture's rather clear. And of course, we all know also about the migration in the 1930s with the Dust Bowl, a similar pattern to this. And the only point that I'm making here, because we don't know yet exactly what the migration patterns are going to be in the future, but the United States has handled at least domestic migration between the 1950s and the 2010s and so on, has dealt with it in the past. Admittedly, imperfectly, there are frictions and so on, but we have dealt with it and survived it, and in some cases benefited from it. And this may happen again in the future. Internationally, that's a major research project. Migration will occur. Another point I want to make here is on earthquake funding. I talked about that, and it's interesting to just a second here. This shows the NEHRP funding over the last about 20 years, and it's the enacted NEHRP funding, and you can see that it's been slowly increasing, perhaps not sufficiently for some of us, but it's averaged on the order of about roughly $100 million, $120 million a year for NEHRP funding. This is research funding, gradually creeping up to perhaps $150 million. And it's interesting to compare this with the research funding for climate change. And that is shown here on the right. And this is the only for the last few years. The research funding within the US government Global Change Research Program. And the axis is an order of magnitude different. Climate change research is on the order of 30 times larger in the last few years than the NEHRP funding. And so much larger funding. So within the federal budget, climate change research funding is vastly larger than earthquake-related research, or at least NEHRP-related research funding. Now, I would not be too concerned about this. First of all, this comparison I've just made is a rough comparison. I don't have all the numbers that I'd like to have. Second, federal resources are not a zero-sum game. If we have, for some reason, our earthquake hazard or earthquake risk is perceived to become significantly more important, such as after a major earthquake in the United States, our country, our budget is elastic, and the funding for recovery, mitigation, research, and so on can definitely increase. And also, by the way, it may be appropriate that it may very well be appropriate. The climate change funding is significantly larger than earthquake related funding. Why? Well, first of all, climate change has only come on the scene in the last perhaps decade or so as a significant hazard and for decision makers. And so therefore climate change is playing catch up related to earthquake funding, which has been certainly funded for a number of decades now. And second, climate change impacts are broader, probably larger, and actually may pose an existential threat to the United States or humankind, or at least certainly some countries. And whereas I don't think anybody envisions earthquake as an existential threat to the United States. It may be for some places, but not the United States. So for these reasons, this relative difference in research funding should not be seen as a threat by anyone. Let me just adjust my screen here. The last effect I want to discuss is fire following earthquake, climate change effects on fire following earthquake, to which I've done some work over the years. And that work included the Shakeout study in Southern California in 2008. Now it's 17 years ago. Sorry, 16 years ago. Many of you are probably familiar with this. It shows that on average, under average conditions, we'll have on the order of, well, over 1,000 ignitions in a significant shaken area, which will, under average conditions, lead to the loss of the equivalent of perhaps over 100,000 single-family homes, and economic losses in 2008 dollars on the order of $60 billion. More recently, a similar study was done for the area called the Haywire study. Population in the Bay Area is less than Los Angeles, or the Southern California region. So there are, but still, we're talking about on the order of 400, 500, 600 fires compared compared to the fire service resources, and we wind up getting losses here that show that losses may be as large as $30 billion. Now, when I did these studies in 2008, and this one's published in 2017, both studies met with quite a bit of skepticism. And I was very surprised that there was so much skepticism about these studies. Why was I surprised? Well, I know the history. Going back to 2006, when of course we lost 28,000 buildings at that time, and the San Francisco earthquake actually was the cause of the 1907 financial panic, and so on. The 1906 earthquake had far-reaching impacts, but it was all due to the fire. 90% of the losses there were due to the fire. And of course, people say, well, that was 120 years ago, or, it's not the same today. But, and of course, we have loss of over 100,000 lives in the 1923 Tokyo earthquake. This is a recent paper from BSSA on that topic. And in 1989, we had the Loma Prieta earthquake with the fires there. And of course, in Northridge in 1994, we had fires. And we also have fires on an ongoing basis in our cities. This, for example, is just one fire in San Francisco a couple of years ago. And look at the size of that fire. And of course, in 1991, we had the first Interstate Bank high-rise fire, where one ignition in one building required the response of half the Los Angeles City Fire Department to fight that fire. So again, when you know this background and these things that are happening, and also, of course, when you look at our cities, you look out the window at San Francisco, and to quote the fire chief of San Francisco, the city is built to burn. And he means that not just figuratively, but looking at this, but literally. If you look at the age of buildings, the magenta are all buildings that existed in 1906, where the fire didn't spread, but will now have ignitions and are vulnerable to a large fire now in San Francisco. And if you look at Los Angeles, well, we all see different things when we behold LA. But when I look at Los Angeles, I see mile after mile of very dense, low-rise wood frame construction. In other words, fuel. I hope this doesn't happen, but we have potential here for huge fires in the really densely built up areas of LA. LA, people think of Los Angeles basin as sprawling and spread out, but really it's actually quite dense aggregations of fuel. So for all these reasons, this skepticism, and just continuing, of course, East Bay Hills fire in 1991, Santa Rosa Tubbs fire in 2017, Camp Paradise fire in 2018, where we lost 18,000 buildings. And just a few months ago, Lahaina, again, all of these are wildfires, admittedly a different situation. These are all these Santa Ana or Fern wind conditions. But they're only a single ignition, as opposed to the hundreds of ignitions after an earthquake. So for all these reasons, that skepticism surprised me. And I think I've been trying to show you some of the evidence why the fire following earthquake is a serious risk. And the climate change impact on it is significant. Let's take these. These analyses were done under average wind conditions. There has not yet been an analysis of the fire following earthquake problem for the Bay Area or Southern California under a Santa Ana type wind condition. It's never been examined. And currently, there are analyses of the seasons of these Santa Ana type wind conditions. This is a paper, for example, from 2022. And what they have found is that climate change is going to increase the number of days where we have Santa Ana type wind conditions from the current about 1 day in 10 in the year, 36 days during the year, 10% probability of Santa Ana wind condition, to within about 50 years to double that. So climate change is going to increase within a few decades. The potential for, well, not the potential, the distribution of Santa Ana type wind conditions by 50% and then 100%. And so we are now approaching a 20% probability of an earthquake during a Santa Ana wind condition. And I've shown you the losses under average wind conditions, and it has yet to be examined under these high wind conditions. But we know what the high wind conditions do when you have only one ignition in Paradise or in Lahaina. So climate change is the fire following earthquake problem is probably most impacted by climate change. Put it another way, climate change has its worst manifestation for earthquake risk in the fire following earthquake phenomenon. And it's not just this one study by Domino, there's other people involved. There's a number of studies about how climate change is going to change and increase Santa Ana type wind conditions. So, in conclusion, climate change impacts or effects on earthquake risk are surprisingly spread across the entire spectrum of earthquake effects. That all of these things are actually exacerbated by climate change. The trends I see in all of these phenomena are exacerbation by climate change. And of all of these, landsliding, liquefaction, tsunami risk, and so on, the one that seems to be most exacerbated is significantly increased fire following earthquake risk. So with that, I'd like to conclude. Thank you very much for your time. And if there's any time for questions, I'd be happy to respond to those. And I'll stop
Thank you,
sharing
Charles.
there. Sure.
Thank you very much. That was very interesting. So,
My pleasure.
Gabby, do you have a synopsis of the questions, please? I saw a couple.
There is one question. Ken, do you want to ask your question or I can read it?
Can you hear me okay?
Yes.
Okay. Well, I phrased it as, is there a way to sort of break down Santa Ana conditions to mild or moderate or severe to tweeze that apart more? The way that you just explained it to us is that it's sort of an on-off switch. It's either yes or no. But really, we know from living here that you get some mild Santa Ana condition days, far more of those days than you do the severe Santa Ana days. So I just wanted to ask you to say more about that and how that will change with climate change. Thank you.
Oh, it's an excellent question, and you're absolutely correct that Santa Ana is just a broad brush that we're using to characterize a very complex meteorological phenomenon. There's the microclimatology of in any Santa Ana wind condition, the winds are going to be different at different. Every city block almost is going to have different wind conditions. And a quote red flag or Santa Ana wind condition, they're not all the same. Some of them are more severe than others. Some of them may be more severe in certain parts of Southern California than in others, and so on. So, if to really analyze this, we need to develop probably a stochastic database of microzone Santa Ana wind conditions that would then be used in a Monte Carlo type simulation. The fire following analysis, the framework for the fire following analysis, which I could go into, is rather complex, is a Monte Carlo simulation. So the wind, and actually currently the analyses that myself and others do for fire following earthquake, we do sample across the wind distribution. So there are a few of the samples, there are tens of thousands of samples, a few of them take into account strong wind conditions like Santa Ana's, but it's only a small fraction. So it's not a scenario, it's probabilistic weighting. To condition the analysis on a Santa Ana wind condition would need a database of detailed Santa Ana wind characterizations for the region. I hope that responds to your question.
Yes, thank you very much.
Sure.
Charles, there were also some questions about it. Do you do presentations for insurance industries or other agencies like Forest Service, Bureau of Land Management, city governments?
Short answer is yes. A little bit long, just a little bit longer answer. Yes, I've virtually every large insurance and reinsurance country in the world, sorry, not country, company, have been clients of mine over the years, and I've used these results. The insurance industry is very concerned about this problem, has been for many decades, and knows more about it than probably anybody else, partially through my work and others. And they're on top of this, so they are adjusting your rates based on this work. Actually, I've been invited to lecture at Lloyd's of London on this topic, for example, and many other places. You asked also about I've worked with and informed and worked with many of the large fire agencies on the West Coast, San Diego, LA County, LA City, San Francisco, and all the way up to Vancouver, Canada, and government Cal Fire, OES. So various emergency personnel over the years, I've spoken to them. They know this. They take it under advisement. I think often not much is done because
wheel alignment.
they have a lot of things to deal with. And short answer is yes.
Thank you.
So thank you, Charles. That was a fabulous presentation.
My
So
pleasure.
we have now arrived at our Quake Break, which today is being hosted by Gabrielle Tepp, who is a staff seismologist at Caltech and oversees the daily analysis and reporting of all earthquakes detected by the Southern California Seismic Network. Gabrielle?
Great. Thank you, Margaret, for the introduction. We can get slides, that would be great. There we go. Okay, so I'm going to go over some of the seismicity for this past quarter. So that's December of 2023 through the present. This map is just our, this is just our station. So our station coverage, our network in Southern California. And this red pentagon is our reporting region. So the Southern California Seismic Network has to report on all earthquakes within that region. Okay, so this quarter we had almost 3,500 earthquakes. This number is from yesterday, so we'll probably hit 35 by the end of the month. And then about 123 core blasts we also recorded. So of those earthquakes, about 340 were a magnitude 2 or above, about 47 were magnitude 3 or above, and about 10, or exactly 10, were a magnitude 4 or above. To put this in a little bit of context for the large number of magnitude 4s we've had so far this year, in 2024, so 9 of these magnitude 4s, which you can see in this list below, were since the beginning of 2024. And in 2022, the entire year had 9 magnitude 4 earthquakes. So we're getting a lot. We've been getting a lot of this year. So on the left here, you can see just a map of the seismicity. And so this is, more or less what we expect. We see a number of earthquakes along San Andreas, many along the San Jacinto, and then the Elsinore. So those are your 3 faults that are most visible in the southern part of the map. And then up in the northern corner, or the northern part, you see a lot of ridge crest aftershocks. So that's that little line up there. And then a bunch of other ones on other faults in the region. So the average rate of earthquakes we've had this quarter is about 40 per day. And then the maximum we had was 300. And so this was the El Centro swarm on February 12th. And so you can also see this on the plot on the lower right. So the orange is just the daily rate, and then the blue dots are the magnitude 3 and above earthquakes. Okay, so I'm just going to go through a few of the magnitude 4s in a little more detail. So the first one I have here is the 4.6 Malibu earthquake sequence. So this was on February 9th. This one had 47 aftershocks. The largest ones were a magnitude 3 and a magnitude 3.1. And this earthquake occurred near the Malibu Coast Fault Zone. And this is a pretty typical earthquake for this region. So I think this fault zone, or at least within, I want to say 10 kilometers of this earthquake, historically, the largest earthquake was like a magnitude 5.3. So there have been a few other magnitude 4s in this region as well. On the left plot here, you can see the Did You Feel It reports. So this was reported felt shaking through the USGS Did You Feel It website. And then on the right is the early warning. So we did actually get an early warning system activated for this earthquake, and a lot of people were warned. So you see the black circles have the amount of warning time, and this blue shape here just shows the initial MMI3 warning area. So alerts go out to cell phones at an MMI3. So this is the area that got alerted for this earthquake. So we can get to the next one I have is the El Centro swarm. So this one was down here south of the Salton Sea in the Imperial Valley. So this is a region that's well known for swarms. We get them every, few years or sometimes more often. It's a very complex region where the San Andreas Fault turns into the Imperial Fault, which is the southern part of the plate boundary. So it's very complex tectonically, so that's part of the reason why we get a lot of earthquakes down here and a lot of swarms. So for this one, we had 300 earthquakes in about a day, as I mentioned earlier. 63 of these were greater than a magnitude 2, 13 were greater than a 3, and 3 were greater than a magnitude 4. So it started with a 4.8, which was the largest, but there were also 4.1 and 4.6. And something to kind of notice here, if you look at the times, so these happened just after midnight. These first 6 events happened within about 6 minutes, 6.5 minutes. And the first 4 of them happened within 2 minutes. So there were a lot of some decent sized earthquakes right in a row in a very short amount of time. This right here again is the Did You Feel It map. So a lot of felt shaking in the southern part of the region. And then this was our shake alert region. So this one was actually large enough that it sent out shake alerts through the WIA system. And that's what this is showing here. So this is the MMI4 marked with the blue. So there were also phone alerts sent out to an MMI3. So that's a much larger region. But this one actually sent out a WIA alert, which is what's shown here. And I guess we can go to the last one. Okay, so this one I just wanted to mention a few of the San Bernardino earthquakes we've had in the past couple months. These were all pretty close together, so I put them together, and they all also had shake alert alerts that went out. I felt the 2 magnitude 4.2s. And these, as you can see, a lot of people in the LA and San Diego areas felt these earthquakes. So the first one was this one to the north here, up near Lytle Creek. Then we had a couple of weeks later, the one that was right under San Bernardino. And then a few weeks after that, we had one out near Ontario that was a bit smaller. All of these, so the 4.2s were both in the San Jacinto fault zone, but they were on different segments of the fault. And then Ontario was on a different fault in the area. One thing that's kind of interesting to note about these, there were a few people at least who kind of commented that there was a lot of shaking for a magnitude 4.2 earthquake. And there are different ways that we measure magnitude. So these final magnitudes that we we put out are what's called a moment magnitude. And so these are calculated with low frequency energy. The other common magnitude is a local magnitude or a Richter magnitude, and that's calculated with higher frequency energy from the S waves. And that's actually closer to what you feel as shaking. You're more likely to feel the high frequencies as shaking than the low frequencies. And in this case, the moment magnitudes were 4.2, but the local magnitudes were more like a 4.6 or a 4.8. So these earthquakes just had a lot more high frequency energy than is typical for a moment magnitude 4.2 earthquake. So, and that's all I have.
Thank you, Gabrielle. And I will mention also that since December the 1st, we've had actually 11 triggered shake alerts across the area. You may not have gotten one if you were not in the intensity 3 of shaking, but 11 were issued since December the 1st. So I'm going to turn this now over to Heidi to introduce our next.
Margaret, we just really quick,
yeah.
there is a question and the Q&A. That would be good to maybe.
You want to give that to Gabrielle?
There is one question. Is there a website that can be accessed to view data from these sensors, open source or vetted?
Yes. So I guess it depends on exactly what you're looking for. The Southern California Earthquake Data Center has a website. I can put the link in the chat momentarily, but that's where you can go to get all of our waveform data and our earthquake catalog. And then I don't know if you can search for shake maps there, but you can get some other things. And all of our products are publicly available though. So the SEDC would be the best place to start if you're looking for data. If you just want to look at like, if you're not like wanting to do something with the data, but just look at it, there are maps on there. And we also do live waveform feeds through YouTube, which you can also check out through links on the SCSN website. So I can put those in the comments below.
Thank
and
you.
we're
Yeah,
on
that
social
would be great.
media. We're also on social media if you want to follow at Caltech Seismo. We put weekly earthquake maps and other information.
Thank you.
Before we move on, just a note that I've put the link to the survey for today's workshop. Before you leave, please click that link. It will only take you a few moments and we'll remind you again later. And now we'll move to our next presenter.
Well, our next presenter is Pauline Louie, and she is with the Office of the U.S. Office of Community Revitalization, where she has led work in resilience, sustainability of disaster housing recovery, and community development. She's managed several federal and state task force overseeing recovery from following hurricanes and wildfires. With all of the things that she manages, she's also our coordinator for Shakeout and events coordinating for our programs as well. I would like to turn this over to Pauline. We're very interested in her presentation on go ahead on her area.
Just want to
Go
say,
ahead.
Pauline, it looks like maybe your camera has frozen. Just make sure that maybe you turn it on and off again. Are you there? She was just with us, but be her connection right. Maybe she'll be back. We'll wait just a moment. There is while we wait for Pauline to return, Gabby, do you want to go ahead and ask the other question in the Q&A? for our other.
Yes, we have a question for all our panelists. With climate change and recent disasters, insurance companies are leaving the state of California. How can we assist our communities with these changes to protect their properties in the future?
Do you want me to speak to that?
Sure.
Well, yeah, we have a problem. And as a matter of fact, I live in Berkeley, and we had a block meeting the other night about this problem. Three people on the block have lost insurance in the last few weeks or months. And I lost it 2 years ago and had to scramble. So so the meeting was called the Firewise Community, and we were discussing how to collectively inform everybody in the neighborhood using information from OES and CAL FIRE, how to improve their fire resistance of their homes. And this mostly has to do with WUI fire, wildland urban interface fire, but it also is almost equally beneficial for fire following earthquake. So to put it another way, climate change is going to exacerbate fire across the board, as fire after earthquake and non-earthquake fires. We have to manage our vegetation better, and we also have to improve our fire service and response capacity. We have probably in California, we have probably the best fire service in the world. They certainly get a lot of practice with the wildland fires. They are really good, but compared to the problem, they, especially for the hundreds of ignitions we're going to have after an earthquake, they're completely overwhelmed. So we have to improve the neighborhood or citizen response team training and grow it larger. These are called NERTs or CERTs. We have to grow them much larger. We have to educate, starting from primary school. We have to start educating people in basic fire safety in much more than we're doing now. And we have to educate people to manage their fuel around their houses, both vegetation and other things, much better. We also have to improve our building codes, and we have to have this. I can go into detail about equipment that our fire services need that they don't currently have, especially with regard to the interface between fire fighting and water supply. And I'm sorry if I went on. I could keep going on for much longer, but I'll stop here.
Thank you, Charlie.
Pauline, are
So,
you
Pauline,
back?
you are back. Thank
I'm
you.
back, yeah.
Yay.
I know,
ahead.
sorry about that. I don't know what happened, just right as Heidi was giving the introduction. I'll go ahead and proceed, yeah?
Yep.
Okay, thank you. Hi, everyone. Pauline Louie here, Environmental Protection Specialist from the U.S. Environmental Protection Agency. So greetings from the Office of Policy. My office is in Washington, D.C., but for those of you who know me, you know that I'm a California gal, and I spend part of my time here in Los Angeles and part of my time in Washington, D.C. I'm so happy that Dr. Dengler and Scalthorn preceded me and to talk about climate change, because I was really scared that all of you would be expecting me to provide all the science behind the climate change and ask me the hard questions, but I'm happy now that they can answer those hard questions. If you don't remember anything else from today's meeting, let me provide you with this. Climate change is not doing anybody any favors, earthquake or tsunami wise. And we can debate about all of that, because you may be still thinking like, well, what does that have to do with, one to the other? But I'm here to say that, as everybody else has been saying today, it's integrated. So these things, and I'm going to be racing through these slides. I apologize, but I'll put my contact in the chat, and we can all have conversations afterwards. But I'm going to talk in particular about tsunamis and why climate change is perhaps making it may not change the tsunami in itself, but it sure is changing our vulnerability to it, like others have been saying. So in this slide, I call it the compromised coast. So we've already talked about sea level rise, but there are other things that climate change is causing already around the world. Coastal erosion, storm surges is perhaps kind of a slightly different form of what communities might see in a tsunami. They're kind of the mini versions, which our friends out in the Atlantic seaboard see all the time. Many communities are already experiencing the shoreline degradation, and we'll talk a little bit more about saltwater intrusion. Next slide, please. So if we're talking about tsunami mitigation and tsunamis and such, and you're thinking like, well, is it kind of too far of a reach to talk about climate change and climate resilience in this context? I would probably offer no. There are some things in which we can be working towards, whether it's under the guise of tsunamis or under the guise of climate change, that actually have benefits for both. And so this is my little crude Venn diagram here in terms of some of the activities that can be addressed. And I'm going to share a little bit about what is available right now, if just in case you're feeling kind of depressed about all the doom and gloom talk this morning. Hopefully I'm going to offer you maybe a little bit of light, or at least some funding and some resource opportunities. I saw in the chat already that people were talking about changing zoning, changing land use, and absolutely those are things that the two sides share in common. I'm going to talk a little bit about how open space, tree canopy, green infrastructure, and if you're unfamiliar with that term, green infrastructure, it's just to discuss about how nature-based solutions can actually have a function that can be mitigating towards some of our risks. Next slide, please. So this was just a couple of pictures from a report that EPA had put out, my office had put out late last year, a disaster resilient design concepts. There were great pictures that kind of showed, they weren't talking about tsunamis in particular, but they were talking about storm surging and flooding and areas that do have coastal edges. That what are some things that can be done, especially not just along the coast, but further in where there are riverine areas, or where you might have intrusion, the seawater intrusion, or perhaps like what would happen in a tsunami, where the water is getting pushed way inland. So you can see here that the graphics do show a lot of tree canopy, a lot of green, and that design in itself can perhaps slow down two of the greatest threats for the tsunami. One is slowing down the water that's coming on land, and two, it's the debris that it picks up along the way. Next slide, please. So I'm going to talk about a very large grant program that EPA has out right now currently. And then secondly, talk about a technical assistance program that my office is working on that accompanies that grant to help communities try to sort through what projects might be appropriate for this type of funding, how to be competitive, how to get themselves together to apply for it, because as many of you know, it's not a piece of cake to apply for federal funding. Next slide, please. Okay, so there's the community change grant out right now, and I will just preface this by saying that we in the environmental side, EPA, we've never seen this amount of funding in such a short period of time need to be out into the communities, out in the streets, out to our partners to kind of get working on. And so this is really an unprecedented time that was made possible through the Inflation Reduction Act, IRA. This particular grant is coming out of our Office of Environmental Justice and External Civil Rights. And it is $2 billion in grants. That's not even the entire amount of the appropriation that was given to us. It's wild, but $2 billion in grants. And you can see that depending on what the project is, it's a lot of money, either 10 to $20 million or $1 to $3 million for more programmatic and engagement types of activities. It's a 3-year grant. The key thing here is that it's directed toward disadvantaged communities, and we can talk offline as to, you know, what the definitions are. But one of the eligible activities that is included is climate resilience and adaptation, many of the things that we talked about today. Let's see. Okay, next slide, please. So we've already talked about kind of what that big grant is. And in addition, there are these technical assistance programs. There's one that is part of the community change grant. It's just the general technical assistance. You'll see it if you went to that QR code into that website. And there is this other one that I thought would be really relevant for this audience, which is the equitable resilience technical assistance. And this one is particularly for communities that have experienced disasters in the past, perhaps either caused by kind of climate stressors, or that the climate stressors have carry in themselves a risk of making the situation worse. So there are 50 projects that we are looking, 50 communities, I should say, that we are looking towards. And next slide, please. Thank you. Thank you, Mark. This is the timeline, and it's pretty fast because the community change grant is going to be closing in November. So we need to get the technical assistance out way before then, so that we can help you if you were going to apply for the change grant, you know, to kind of get yourselves ready. Now, I just have to say that it is, if you partake in any of the technical assistance programs, it's not a shoe-in that you will get the grant. It's not an endorsement or anything. It's really a tool that's there available to you to kind of help, you know, just to get all the I's dotted, the T's crossed. Or if you're having trouble identifying partners that could really make your project sing when you send it in for the application, that's what it's there for. So we want to make sure that we're hearing from all of you. We're getting out there. It's a very low barrier type of technical assistance, and we are certainly here to kind of help talk you through whether or not this is appropriate for your community. Next one. Okay, this is just a breakout as to how they were trying to divide up the 50 communities there. And for all of us out in the Western Alaska Pacific Islands, they're looking for 17 projects. I don't know if this is hard and fast. You know, there might be more opportunities for other communities, but certainly first come, first serve on this. Next slide, please. All right, this is just a schematic, and I will just warn you that, you know, this slide deck here is tilted to a lot of wildfire type of activities, but please note, and we can certainly talk about this offline for your particular community, is that, you know, these climate resilience or adaptation projects, you know, writ large, can be a multitude of different things, including if we're talking about kind of tsunami mitigation or how to reduce the risk to your coastal areas, is that maybe a lot of disadvantaged communities, you know, maybe very few of them are going to be located on oceanfront property, perhaps. I'm just going to make that a general statement. However, because of the nature of tsunamis, the inundation area could be far, far away from the actual coastline. So there are things like, you know, can we build in open space with a lot of, you know, canopy or green infrastructure in a place that we might see the water coming in? That might be some of, it might be an eligible activity or a project that might be appropriate for your community. Okay, so I'm not going to go through kind of how the sausage is made on the technical assistance, but as you can see, it's not a heavy lift here, but it does allow us and our contractors to come out to meet you, to provide some assistance and support to the planning that you're going to have to do for all this other funding. Next slide. So this is just the just some details in terms of the particulars for this technical assistance. Like I mentioned, disaster-prone areas, disadvantaged communities. And I like to kind of encourage you too, if you're thinking, well, I don't know if my community is all disadvantaged or whatnot. It's okay. We should talk about it because, this particular technical assistance or this grant might be part of a mosaic of other funding. Say you have like some FEMA BRIC funding or some other funding at the state level that might work well with this. So we definitely want to make sure though that you're working on it starting today. Next slide. And this is some information here. I think the slide deck is going to go out to you, but some websites. The email address that we're kind of just consolidating all interests and all inquiries is equitableresilience@epa.gov. I'll put my email in the chat so that if you had questions about all of this, you can reach out to me. And I think this is the last slide. Is it? Yeah, that's it. Thank you. And I'll let Gabby and Mark decide how to handle questions.
I don't think we have any specific questions for you, Pauline. And just as a matter of time, we'll move on. Thank you so much. This was a great
Mark,
capping of our earlier presentations too, in terms of what we can start to do about the issues. Heidi, do you have a question?
yes, I do. In your definition of disadvantaged communities, can you go into looking at a larger group within that community? I'm thinking about people with disabilities. So, some of the information, whether, that you can take a look at and do the research in that group of disadvantaged individuals who would certainly have difficulty possibly evacuating, or moving to a safe space, and what the information that they need, and would that be something that could be under those grants?
Yeah, so I think disability isn't in the first cut of kind of how they define disadvantaged communities. However, there is a lot of room to kind of discuss kind of like there's going to be a risk assessment. So, in terms of vulnerability or vulnerable communities or sub-communities within that population, there is going to be room to talk about that. The definitions on DACs, disadvantaged communities, are fairly strict. I think that they may be statutory or at least regulatory. So when you go into the community change grant frequently asked questions, there's a whole section as to how to calculate or how to kind of determine how to draw the boundaries around that disadvantaged community. But certainly those who, seniors, the disabled, certain other populations, sometimes like tribal members and such, there is room to talk about kind of the, the details, the specifics of what makes your community so much more at risk. Thanks.
Thank you. We really appreciate all the information that you gave us. And now we are moving on to Mark Benthian,
Yeah.
who was going to talk to us about some things in his bailiwick.
Sure.
So
thank you, everybody. And just to move quickly as we allow a little time for discussion, just got to give an overview of some activities and opportunities that you should be aware of, things that are coming up this year. As always, I know some of you are new to Earthquake Country Alliance, so make sure you know about our website in both English and in Spanish. We also support the tsunamizone.org website and shakeout.org, all from the statewide California Earthquake Center, support from Cal OES. And of course, we'll talk a little bit more about those activities. In addition, we have statewide sector-based outreach committees, and we encourage you to participate with us through those committees. If those of you in those sectors reach out, the webpage here, or just Email us if you'd like to be a part of that, making resources and activities. One example is the accessibility committee that Heidi and has been a part of for many years, and many of those attending today, developing resources, and really has been instrumental in expanding our guidance for self-protective actions and other aspects related to how we provide information that's accessible to a broader group, broader community, including materials that we have that are related to accessibility that are also for disabilities, also now available in many languages. There's a webinar that you can find at earthquakecountry.org/accessibility from last year. And also coming up, if you are in Southern California, we would love to have you with us at the Abilities Expo. This is an annual event at the LA Convention Center. We've had a large booth at for going on 10 years. Multiple partner organizations such as CERT teams and the Red Cross and FEMA and Caltech and many groups, and any of you as individuals, welcome to come and support the activity. We have presentations all weekend. If you're interested in that, working with us, it's a really great way to learn about our general messaging, and in particular the messaging for people with disabilities and the conversations that we have. And if you would like to have a presentation or have us come out, our events bureau come out and have an information table at your event, or to speak online in an online forum or in person, you can go to earthquakecountry.org/ECA-events. Just click the link that's on the homepage lower left to make that request. Coming up, our annual ECA mini awards program, we're making some changes to it so that you can better customize the materials that you request. These are packages that you request that we then buy for you, the company ship to you, so that we're not having to deal with exchanging money, but you get the materials and then implement a plan and then share that plan in a future meeting like this. And this is for mitigation, largely for non-structural, like securing TVs and bookshelves and kitchen cabinets and other items, as well as for educational activities. A lot of people will request materials for youth, such as the Rocket Rules materials, but we've also made signage for a community college in the Bay Area that we're having available now. What to do during earthquakes, to go on near the exit doors like you have for fires, and we can print those for you and customize for you. So the main thing is you'll get a link if you're an ECA member when the new application process opens coming up here in March. And we're likely to have applications for a short period where we'll be selecting the first groups, but try to keep that open year round. So when you have your idea, you'll be able to do that. This is just a list of last year's presentations. So different organizations, nonprofits, cities, schools, and it really can be one of you in your organization or someone you know. So when you get that message, please do share it so we get lots of applications to choose from. Hopefully, you know that our guidance is organized around the 7 steps to earthquake safety, which you can find fully fleshed out in English and in Spanish on our websites. And a lot of that is now also showing up in our materials that you can find at earthquakecountry.org/languages in 16 going on 18 languages. I know that sounds like a song, but we're talking about languages, and adding additional languages through the support we get from Cal OES and FEMA to all of our documents, and adding new ones all the time. And of course, mention the Rocket Rules materials that we can make available as mini awards, but you can get them at any time, download, or even order printed copies at rocketrules.org/earthquake. We are also fortunate this year to have funding to support a new order form for our materials to print and ship them to you. So we're going to be working on that, and we'll let you all know about that too, because it's something we've always wanted to do, but we got funding from Cal OES and FEMA now to be able to do that. Also, just FYI, if you aren't aware of how to find out where your local faults or landslide or liquefaction or tsunami potential is and other hazards, you can go to My Hazards. You can see the link here. or even just search My Hazards, you'll find it. Type in your address and it'll tell you right where you're at. You can see a little bit of a tsunami zone here, but you can really get detailed information on your tsunami hazard and risk at tsunami.ca.gov, and this great new interactive map from the California Geological Survey. That also lead up to that March 23rd to the 31st is Tsunami Week and the weekends around it. It's a little bit extended time, Tsunami Preparedness Week, where you can have activities on your own or coordinated with your local organizations and agencies. You can hold a tsunami walk. We provide guidance on how to do that if you're near the coast. But if you're not near the coast, there's something you can do. We have lots of different activities that you can kind of coordinate as a part of your participation. And just like Shakeout, you can go and register your involvement. We really encourage all of you on today's workshop here to participate, to think of what you can do. Just because you live in an inland area doesn't mean you might not be near the coast at some point, or those that you talk to and educate and your family, friends, and colleagues might need to know what to do. So having a discussion about this, how to drop, cover, hold on, then if you feel strong shaking near the coast, then get to high ground as quickly as you can and stay there. As Lori mentioned or demonstrated so perfectly earlier, the first wave may not be the largest. It may, in that case, was the fourth wave. So stay away. Lots of guidance on all of that at tsunamizone.org. And I just want to acknowledge that Lori's involvement and leadership of the Redwood Coast Tsunami Work Group that has really expanded our tsunami messaging from when we were first organized. So thank you, Lori. Also, this is the 30th anniversary of the Northridge earthquake all year long. It was, of course, January 17th, 1994. There's a lot of things that we're doing and more to come as we develop this further. But with some support from CalOES, California Earthquake Authority, Optimum Seismic, and others, which could include your organizations, we're ramping out and holding a lot of different types of activities. One, the kind of a cornerstone will be many what we call Quake Heroes Expos that takes the Quake Heroes film, what we've created at the Statewide California Earthquake Center and our production company, Romascope, stories of people who experienced the Northridge earthquake and tied to the 7 steps, really inspirational. We tie that with a preparedness fair where people can take immediate action following seeing the film. And you can learn more and find out about this at quakeheroes.org. Just a list of what we've had already. That one coming up next is a partnership with the Rancho Mirage Emergency Preparedness Commission and the Coachella Disaster Preparedness Network on March 30th out at the Rancho Mirage Public Library. So, but many others coming up and being scheduled, and reach out to us through the quakeheroes.org website if you're interested in working with us. Some will have funding for, some not, so we can work together to figure out how to have that event for you. And then many other versions of that film screening. There's a webinar series underway, and we offer 7 steps to earthquake safety presentations that will highlight lessons learned from Northridge. And for those of you from other parts of the state that may be with us, we are working on also leading up to the Loma Prieta earthquake from October 17th, 1989, which happens to be one of the years that it lands right on Shakeout Day. So we're looking at what we can do for that anniversary as well. And of course, Shakeout registration is open. You can go to shakeout.org already to register, but that will be in October. You can have your drill any day of the year. So if you have a large earthquake drill in April, you can have that and register that as part of your Shakeout activity. Okay, so a lot of links as I was talking, Gabby was putting into the chat, so you can look there and do email about if you have any questions about the resources, info@earthquakecountry.org to be able to get those. So we'll just start the wrap up. I'll turn it back over to Heidi.
Okay, well, like it's a lot of great information, but this is also a time that that we also want to be able to get the word out about your short, announcements of anything you have calendar, something, something maybe that the it within any of the presentations, was there something that you had said, that's something I got to do, so we'd like you to share with us some of the things that you have going on and some of the things that maybe you learned today. So
And we have a very
I
short
will turn
time
it-
for this, so anyone who,
Yes.
just keep it super brief, and maybe even you can all put things into the chat as well if you're able to put a link there for us.
So does anybody have? Sorry, go ahead.
Yeah, into the chat, I did put an announcement. There is a Readiness in Japan and Los Angeles webinar that will compare the readiness both in Japan and Los Angeles for earthquakes.
Right.
I put the location for that, and it's in the chat, and that's on March 12th in the evening, hosted by the Japanese consulate and LA City EMD.
That's great. Thanks, Margaret. Everyone look for that. There's also a follow-up to Heidi's question about disadvantaged communities and people with disability. Any other, if you like to just shout out something too right now, if anything you'd like to share coming up, or something you're doing or aware of that might be of interest to the group.
Mark, this is Yvette with Cal OES.
Hi, Yvette.
Hi, just wanted to shout out real quick. So we are in the process of doing our fiscal year 24 grant application to FEMA for earthquakes. And so we did send out a request if anybody has any large projects where they needed some funding. And so we just wanted to do one last shout out. If you have any projects that you're unable to fund, that you might need some funding, let us know. We might be able to take on one additional project. And we would need to know no later than probably Friday. So you can either contact me, if you don't have my email, you can contact me through Mark or Philip Labra with our earthquake program. So thank you.
Thanks, Yvette. Anybody else have any announcements? No? Then I think we will adjourn, and our next meeting will be on May 15th. We're looking to do an in-person meeting for that date, so stay tuned. And I want to remind anybody that's interested in joining one of our committees, coordinating committees, to contact Gabby and let her know. And we'd love to have all of you on one of our coordinating committees. So thank you so much, and we will see you in May, if not before.
And if anybody wants to save the chat so you can have access to all the links that were shared, please make sure you do so. Yeah, thanks everyone.
And the link to the survey is in the chat. It's about a little further up there. Please do complete that as we end today. We really value your feedback.
Mark, I have one question, and that is because there are so many links and so forth. I'm wondering if maybe the links can be pulled out and kind of sent in an email as to all, or something as to all of those links that you may have.
We do post the presentation with all of them on the website, and that should be online with the recording by early next week.
Yeah, I understand about the recording. I was just thinking in terms of pulling that out as separate.
Yeah, not just the recording, it's the whole PDF of all of the materials, and we can include the links too. Okay, awesome. Thank you, everybody. We'll go ahead and end the meeting. Have a great rest of your day.